move that one to the side. All right, so thanks again. And I didn't really choose an introductory topic. I actually chose a very advanced topic. Perhaps, um, you can think about this one, what is ahead in the future. So this is about climate resilient design of civil infrastructure. The civil infrastructure is everything, buildings, bridges, highways, all kinds of things that civil engineering works on. And civil engineers design those things and, but um, we have a traditional design approaches, but climate is going to be a big issue. And how do we go about designing our civil infrastructure to address the climate impacts, okay? So this is the topic that I have, and again, this is the most important topic, and this is the most important topic, in the US and all over the world, this is the topic, okay? Um, so before I get started, Chicago is a beautiful place. I always show this one in my presentations because as a civil engineer, you should be very proud of seeing the, infrastructure that is there in Chicago. So a lot of buildings, a lot of bridges, all kinds of, civil engineering infrastructure. So, and then the last two pictures that you see at the bottom, those are my campus. It's right next to the downtown. So it's a very good place to visit. It's the third largest city in the US. And I welcome you to visit anytime you are in Chicago. So my presentation, what I'm going to do is quickly talk about this climate change and impacts. This is the issue that we have to address. Then I'm going to talk about role of design professionals to address the climate change impacts. And then how do we go about designing for climate impacts, okay? That's the one, climate resilient design. And then I'm going to show some examples that should give you some idea about, how to address these issues, okay? And then I'm going to have a closing comments. Okay, so what is climate change and impacts, okay? This is the issue that everybody on this planet Earth is talking about. So the climate change is due to greenhouse gas emissions. Greenhouse gases emissions like carbon dioxide, methane, nitrous oxide, and there are other gases, CFCs. These are called greenhouse gases. There's a, I can explain, it takes time, but greenhouse effect. Basically, these gases reflect back the infrared, radiation, and then it comes back to the Earth, and then Earth gets warmed up. So there are many sources of these gases, but one of the main sources is burning coal for power plants. So that's why coal is considered as really very bad resource to create electricity. In the US, we are shutting down all the coal plants now. So because of this, there's a lot of a push to close down because a lot of emissions come from that. And a lot of waste dumps. Waste dumps, you get a lot of methane out. So there are many sources from where you get these greenhouse gases. So the greenhouse gases emitted into atmosphere are the major problem for these climate change. And then, there is already so much of greenhouse gases in the atmosphere, there is no way you can reduce these gases all of a sudden. So it's even if you shut down all the power plants, that coal burning power plants, and even if you close or take care of all the dump sites and everything, the existing atmospheric greenhouse gases that you have, you are going to see the impacts of those for many years to come. So there are two things. One thing is, if you don't reduce the greenhouse gases, the problem is going to get worse and worse. The greenhouse gases are already very high, and the impacts of that one is going to continue into the future, okay? So what are the climate change impacts of these greenhouse gases and global warming? These are the problems that we are seeing now. Sustained changes in average temperatures. Some place is extremely hot, some place is extremely cold. For example, maybe in some places, I hear last 2-3 years, the highest temperature recorded in some parts of Rajasthan, like never ever recorded in the history of planet. And you will see some places is extremely hot, some places is extremely cold. And you will see, remember my talk today, that in the future, you're going to see even extremely high temperatures than what you are seeing these days. The increased heavy precipitation events. So you will see that, a lot of rain, the storm, there are frequencies higher and intensity is higher. So you will see, suddenly, the rain comes hard and stops and keeps on happening like that. So these things are happening. These were not, never happened. Just an example, Hyderabad never flooded. In the inside the city of Hyderabad, like never thought that, it would be flooded. And, it happened recently. And many parts of in India are getting flooding that was not common at all, right? So if you are a civil engineer, you are designing something, if you look at the history, hey, there is no, precipitation issues, there's no flooding issues. So you assume that one and you design it. But now, this flooding is becoming common. So as a civil engineer, you need to design for these, new flooding things that are going to happen. Increased coastal flooding. The people who is along the coastal area, they're going to be impacted significantly because of the sea level rise and also the, big surge that you're going to have it. So lucky that you are not along the coastal area. If you are a coastal area, I would have advised you to move somewhere inland, sell your property and then move. Bhimavaram is one of the areas where it's going to have a lot of impacts in the future. So, in US, a lot of things are happening along the coastal area. AACE is thinking about, hey, we cannot move a lot of people coastal areas. What can we do? So AACE has the vision of, having a floating cities, having a cities in the water. So go to AACE website, type floating city. They're coming up with a concept into the future. You may have a floating cities. All the buildings are in the water. All the roads, transportation, everything is underwater. So that's kind of things that are coming up into the future. Increased intensity of storm surge, as I mentioned, in the coastal areas, the sea level rise, and then, I don't know if it is common here or not, but in the US, a lot of these, forests are on fire. Never before we had so many fires. California, I mean, if you have any friends or relatives, whole California is burning. And a lot of houses, expensive houses are in these hilly areas, in the wooded areas, and they're all, getting burned out. So a lot of issues, these things. So this is the problem. So just to give you some example of, what could happen. If you're in a coastal area, the sea level is rising and then your surge things are happening. And if you have a roadway along that one, that's going to get damaged. So what I'm trying to say is you are a civil engineer. These things are going to happen more and more in the future. Now you need to design that one. Your textbooks don't tell you how to do this. Okay, this is something that is emerging into the future. We are trying to develop methods that we can use it. Look at this one. This is in Texas, USA, expensive houses. Never got flooded in those areas. Now you see, look at it. Whole house is filled with water. So much damage, right? So this is all due to that greenhouse gases that is being emitted into the atmosphere, having the global warming effect. Consequences of that is all these things. And these things are not common. You don't have the same situation uniformly across the planet. Some places you see the flooding, some places is extremely cold, some places is extremely dry. So you will see these kind of situations all over. So this is what, for example, some places there is no water whatsoever. They are starving. And some places, it's extremely cold. Some places, here in the coastal areas, they have problems. Hurricanes. This is, I think, in Chennai. I took a picture like 3 to 4 years ago, something like that. And these are called tornadoes with the wind, the extreme wind. And then, this ice melting that really leading to the sea level rise. And some places it's hunger. And some places it's air pollution and wildfires. All these things are happening right now. So that's why we need to worry about the climate change impacts, right? And then I just put some pictures of, India. So India has to face these climate impacts going into the future. So, there's Maharashtra, Kerala, Tamil Nadu. In Maharashtra itself, you can see some places, extremely dry. So these things are happening. So how would the civil engineer design the buildings, design the bridges, design the dams, right? So we really need to do this one, otherwise we're going to see a lot of damage. So these are the statistics for US. You can see the number of these events, climate change impacts. You see that earthquakes, tsunamis, or storms, and then floods, and the temperature, drought, for wildfires. You know, those are like shows that, and if you add them up, so this number of these extreme events, climate change impacts, are increasing every year. And you know, even if you put the new data, that shows even the higher numbers. So this, we cannot ignore that, okay, this is happening maybe 1 year, you know, maybe the problem will go away, but you know, this is continuing to get worse. And then, you know, in some cases, damage is so bad, so bad. This is $1 billion weather and climate disasters. So for example, in 2020, we had this many, 16 events that had a damage more than $1 billion. Each one, you know, costed more than $1 billion to fix the problem. You know, when these things happen, there's so much of damage, so much of financial loss, right? So you know, again, you look at these trends, these are keep on going up, right? So, you know, if you want to learn more about climate change, the authentic source is this Intergovernmental Panel on Climate Change, IPCC. So if you're ever interested in, if you're writing a paper or want to learn something more about this climate change, the more authoritative information is from this IPCC. So they generally assess the climate situation every 5 years. Okay, so they write the report. So this report came out just recently. So this assessment report, 6th assessment report. So they give you, you know, idea about, these are all the scientists, independent scientists. This is not a political agency, this is not a government agency, this works under agency of UN. And these are the group of scientists, they collect all the scientific information that is available and they provide the summary of it. So they see that, you know, situation is really getting worse. So CO2 concentrations are highest, sea level is increasing really fast, the ice is melting really fast, and then as a result, you know, we are having all these impacts. Extreme heat is, you know, and heavy rainfall, drought, all these things are happening. So if you look at this report, it's depressing. It's depressing, you know, you wonder, you know, your safety, your survival on this planet, right? So, you know, this is going to be bad. And they projected what will happen into the future. So this one shows, you know, this is their predictions. Again, a lot of people use this as a authoritative, you know, information, okay? So with time you can see, you know, there's the greenhouse gases going to increase, you know, the temperature is going to increase, and this temperature increase is, should not look at the, you know, like a daily weather temperature. This is the global average temperature. Even if the change is more than 0.5 degrees, that really creates the havoc. So you really is a, you know, and then they're looked at different scenarios, you know, a low carbon dioxide emission scenario to high CO2 scenario. You look at this, no matter what you're looking at is, this shows really increasing global warming effect. If you have increased global warming effect, that means you are going to have more and more issues that I mentioned. So really a problem, guys, you know, really it's going to be going to the future. So it's not about us, maybe you and you know, you are going to tackle these kind of problems into the future. You will be forced to talk about these issues. And then, you know, the IPCC said, okay, you need to address the impacts, you know, you need to adopt it, vulnerability, you need to look at, you know, addressing the mitigation of the climate change. So a lot of things have to be done to address this issue. And you probably heard about sustainability, sustainable development goals. So going into the future, if you want to maintain the quality of life for current generations and the future generations, the UN came up with these goals and they said we need to be focusing on all these things, right? So the gender equality, you know, education, and then they have also this issue of climate action. So the future sustainability, the sustainable development is not possible if you don't address this climate action. So this This is, important, and everybody is trying to work on these things, including the climate action. Now, hopefully that gave you an idea about what is climate change and impacts and the role of design professionals. Now, the question here is this, okay? If you are a designer, right? If you don't account these climate changes and you design it, right? So what are your implications? What are your liabilities, right? So that's the big question that is being asked. Now, what happens is, when you are working in engineering practice, engineer Puluju works every day and he is designing and giving to the contractor to build it, right? And he designed it, but if he didn't consider the standard of care, that means, we are given a responsibility to, use our knowledge to, design things that can be safe, right? But if you don't do that one, that's called negligence. And if you, have negligent on your design, then everybody can go to the court and then they can ask for damages. Now, a lot of times you do the design based on the building codes, right? Building codes are standards, and I'm sure you have a concrete design, you have a code, and then steel design, you have a code. For everything we follow the codes. If you design according to the code, does that meet the standard of care? So, always people believe that, okay, I designed according to the code, it's good. But, according to the standard of care, just following the building code is not enough. You need to think everything that could go wrong in your design or when your design is constructed, So that's why satisfying the building codes may not be at the standard of care. So now in the US, all the engineers are thinking about incorporating the climate impacts in their designs, okay? So how do we do that one, right? How do we do this one? This is a new thing that is emerging, okay? How do we do this one? Okay, I want to design taking into consideration of the climate impacts. So for that one, you need to have an idea about regional climate change, right? You need to have a regional climate, what are the things that are going to be happening at the location of your project, right? And engineers should consider all the potential climate impacts that are going to happen at your site, and then, you need to collect the project specific data, and then you incorporate that one into your design, okay? So this is the, issue that is going on right now. And then one of the biggest challenges is that these climate impacts, there is a lot of uncertainty, okay, in terms of, what could happen at your site. So this climate resiliency is basically withstanding, these climate impacts is still evolving. So how do I design it, right? So this is the concept of climate resilience, okay? So just pay attention to this one, because a lot of times we design this. We design for the performance, okay? This is what we assume, that nothing is changing and, design is performing. But now you look at it, if the climate impact happens, let's say there is a climate impact, and then what happens, you're going to have some damage to your structure, okay? But hopefully you don't want it to collapse completely. If it collapses, then it's really bad. And you want to design such a way that after that extreme event recedes, then you want the performance to come back to some level, maybe not necessarily at the same level, but at a satisfactory level. But ideally, you want it to recover to the same level as the initial level, or even better. Now the question is, how do we do this one? How do we design it? How do you design a building? How do I design a bridge? All right. How do I design a bridge if there is extreme flooding that happens, if there is some damage that happens, but how can it come back to its original performance or even better performance than what it's originally designed it for? Okay. This is what civil engineering professionals are being asked to design. This is basically called climate resilient design. Climate resilient design is when, when the climate impacts happens, it will undergo some damage, but it will recover fast, right? So this ability to cope, adapt and grow in the face of foreseeable climate and extreme weather impacts that may occur over the life cycle of project. How long is the project? These civil engineering projects are long term, 50 years, 100 years. We design a bridge, we think it's going to last for 30 years, 40 years, 50 years. So during that time, we need to anticipate what are the climate impacts they're going to have, and then we need to make sure that our bridge is safe. So how do we do this one? Okay, let's say you want to do the climate resilient design. How do I do this one? So there's no good framework that has been developed yet. Okay, there's no code, no guidance. Okay, so this is still evolving. So this is one of the frameworks that I proposed some time ago. So this is how you follow. This is the procedure that you follow. You identify climate change hazards of concern. So okay, you know the location where you're going to put your project, right? Let's say here, you maybe in your campus, you want to have some new building, or in Hyderabad you want to have, or you in Chennai you want to have. So each location will have climate change hazards, different hazards. If in Chennai, I might worry about, these coastal impacts, right? In Hyderabad, maybe the flooding. So then you have to identify, exposed to specific climate change hazards of concern. So you characterize the exposure. So if I have a flooding, what kind of problems that I will have for my structure. So you evaluate the system performance due to the specific climate change impacts that you have identified. Okay, it's like when you're designing it, you take the load, right? Design load. So this is like, what is the climate impacts that I need to consider in my design? So you need to come up with this one. Yeah, this is called vulnerability assessment. So you will hear about this word quite often in climate change designs. It's called vulnerability assessment. So you need to really think about what are the climate impacts that are going to happen at the site that you're planning to build, and then you need to assess those impacts. That's called vulnerability assessment. Okay, now you know that, okay, my structure is going to undergo some damage, so what should I do? So this is called screen different resilience measures. What can I do to my structure? What kind of things I need to incorporate additionally compared to the conventional ones that can address those issues, right? And then you may have more than 3-4 options. And then you find out which one is the best option. So the resiliency measure, right? And then this is called the resiliency measures selection. And then you implement that. So when you're designing, let's say you're building the bridge. So in addition to the conventional design, you incorporate these resiliency features, and then you increase the adaptive capacity. And then what you have to do is, it's not going to, there's no guarantee that it's going to perform well, because there's a lot of uncertainty in terms of these climate hazards. So maybe you expected some, medium level flooding, but there's now much more flooding than what you expected. So only solution to address this one is you implement based on whatever exposure scenarios that you considered, you implement the remedial strategies, but you keep monitoring it with time. Because you keep monitoring it, see if the impacts, climate impacts are changing, or they are less than what you incorporated in your design. This is called adaptive capacity evaluation. So these are the 3 things that you have to do going into the future to address the climate resiliency. So all these things require engagement with the stakeholders. So stakeholders could be public, planners, designers, and owners. Why do you need this engagement much more than conventional design approach? Because in this one there is uncertainty and you have risk, right? You need to communicate the risk, because I don't want to take into account of this extreme event that may occur or may not occur. So I don't want to spend a lot of money making my design very, very conservative. I'm spending a lot of money unnecessarily. If that thing does not happen, I wasted my money, right? So you will always do less than, very conservative scenario that we think of, but there is a risk. Risk means, assumption may not be correct. you may have a severe situation. Under that severe situation, you may have more damage. Hey, be prepared to have this kind of damage. So that damage could be minimized by this periodic monitoring and retrofitting as we go further. So here are those things whatever I mentioned. These are the words about it. How do we do it? Because there are okay. One question I want to mention here is how do we find? Where do we find the if I have a location, how do I find what kind of climate impacts that are going to happen at that location? So really you need to go into these databases. So from these databases, you can go into specify your location and you can find out the information about flooding or sea level rise or surge protection. So what I'm trying to say is there are a lot of resources that can be used to get the information that you need. Okay, so this is not typically done in civil engineering, but we are now forced to address these things. So let me just skip some of these things, kind of the same things that I mentioned in the flow chart, but then I want to go into case studies. Okay, I just want to give you some examples so that you can understand how this can be done. So this is the building. This is a house actually. This is a library building that is being built in one of the places in the US. It's in New Orleans. They're building this one. Okay. And they looked at, okay, what is the climate impacts that could happen at this site? They found out that flooding is a big issue at this location. Flooding is a big issue. Okay. And then they estimated if, in the worst case scenario or in the potential scenario, the flooding level could be this much. So what did they do? They raised the foundations to that level. Otherwise, generally foundations are at the ground level, right? So they raised, thinking that in the future, the flooding will happen. You will have a lot of water accumulated around it. And if you put it in the ground, all the water will enter into the house and going to have a damage, right? So they, they raised this foundation, and this is basically called climate resilient design. So you're trying to address the future impacts now, as a result of this, right? So this is actually built it, and also flooding, you don't want to have a lot of water accumulating, so there's a lot of emphasis on green infrastructure to infiltrate the water, not allow any accumulation of the water. So let me give you another example of the climate resiliency. Okay, so we have in the California, there's a sand line goes like this. Okay, so this is no problem. This has been designed already, and this is what is existing. And look at it. Where is it? It's right next to the coastal area. And then, as I told you, with the climate impacts, the water level is going to rise, and you're going to have a surge. And they predicted this one at this location. If in the future, the train line is going to be inundated with water. It's going to be submerged. How would the train will go? Right? So this is what we are thinking about climate impacts, designing for climate impacts. This is not this is the existing one, right? How do we do this one? Or you can tear down this one, build another one higher than expected sea level rise. So we are civil engineers or creative thinkers. So they came up with this design plan. So right now you have this, the pile foundations and pier, and then this is supporting the track. So what they want to do is they want to lift the track with the jacks like here, and then they want to increase the height of these piers. So now instead of being at this height, now it's going to be much higher height, and this is higher than expected sea level rise. So now the train can go on this one, the water level could come all the way here. Does not matter. Okay, you guys understand? So that's how we are looking at the climate resilient design going into the future. Let me show you another example. This is a project that is being done in San Francisco, California. So what you have is, this is a stormwater project. So you have a stormwater, all the rainwater that gets collected in the cities. they put it into the pipes, right? Underground pipes. And then, they discharge into the bay. This is the bay. So, during the rainy season, there's a lot of water on the roads. They, put it into these underground pipes and then discharge into the lake. So that's fine. So when it's raining, you're able to address the flooding problems in the city, and discharging into the lake or bay is not a problem. If it is a very dry weather, so there's no water in the city and no impact on the bay, so you don't have any issue of water transferring from one location to other location. For example, here you have a dry weather, but sea level is rising. Bay is connected to the sea. So the sea level is rising. This is dry because there's no rain in the city. So if you don't have any system, the water level will rise, and this whole coastal area is going to be, coastal structures are going to be inundated with water. So this becomes really unworkable or unusable. So now what they are doing is, when the water level rises here in the bay, the water goes into this system and stores it, and then you discharge it. Okay, so then the water level in this one, the bay, will never increase, and it doesn't matter whatever you're doing, you can keep doing it because that's not going to be flooded. Now this is another example I want to mention. Here is the conventional way of addressing the storm surge along the coastal areas or along the rivers, right? So basically you put a seawall like this one. So this is the conventional seawall. You put a concrete wall, and then height of it is the same as your surge height. You expect the surge height and put that one. So that's what. How do you know that surge is only this much? Because there is a lot of uncertainty, right? I mean, you make assumptions. What if surge goes higher than this? Then are you going to tear down this structure and then build another one? That's not a good approach. So this one, now what are they doing is that designing with nature or nature-based solutions are being sought extensively now. So instead of having a conventional seawall, they're trying to have these floodable parks. So what you do is, instead of having a wall here, you need to create a park. So if there is a sea level rise, or there's a surge, you're going to have this park is going to be impacted. But there is nothing there to get damaged. So basically you need to have a buffer zone. You cannot have anything close to the coast. So now people are being replaced, moved to higher land, upgraded, and then there should be like a buffer zone, and then they're basically creating these parks rather than building this sea level seawall. So now there's a lot of effort. This is the design that is climate resilient design. This one is not. Okay. So these kind of things are going on extensively in the US. I think other countries will follow very soon. So as I say, if it is typical as usual, buildings are close to the coast and they're going to be inundated. They're going to be, suffering a lot. So they are now moving these people up gradient and then creating this park. And this is the park that they are proposing in New York. In New York, you see this one? So this is all the park. So, if the sea level rises or there is a surge, so this water is going to be in this area. And then New York, has learned hard lessons, and they want to do something about this issue, right? So, Hurricane Sandy, that really flooded the entire city, damaged the entire city, including the subways, roadways, houses, computer centers, data centers, everything got damaged, because of this unexpected Hurricane Sandy. They never expected it. Now the city is really planning so that these kind of things will never happen again in the future. And with the climate change impacts, there is a chances that this could happen more often than not. So they modeled it with seeing the different climate scenarios. They found out that this area, this marked area that is there, that area is vulnerable for flooding. So this is the area. So that's where hydrological modeling that civil engineers do come into use. And then in that area, they are planning to build these parks. So, remember, this is the area. So if you want to say this area, they want to build these parks here. They don't want to have any building in this area. and they want to build these kind of parks. It's interesting how they design this park. You see this one? So very close, you can see have the view of the ocean, but look at how the park is. There are steps, and there's a kind of a nice steps going all the way up here. On ordinary day, you can go there and sit down and enjoy the view. But it is actually serving a different purpose. It's a retaining structure. It's a retaining structure. So you see this one here. Suddenly, let's say, sea level has risen and or surge came. Everybody goes home, right? The water comes here, but it does not spread this side, city side, because this is serving as a retaining system. It's stopping the water from entering into the city. You get it? So that's the beauty of this one. And again, looking at these parks along the coastal areas, there are a lot of parks, and you see this height. That height is mainly to retain the water if there is a surge comes or sea level rises. And then in fact what they're doing is this one, again in New York, and let's say it looks dark, and they have a gates to close the water coming into the city. The watertight gates that are there. And then look at this one. This is the sea level rise, this is the city side, this is the overhead train that is going around. Look at this really bad area, and then whenever water level rises here, surge comes up here, this gets water here and the city gets damaged. Now this is the plan. They want to convert this whole area that you saw, this one into this. So the public can use it. It's a nice, very nice area to use it. This side is the ocean, and look at what they did here on this side, left side, the city side. They put these stairs. So what happens if there is a sea level rise or slight surge? It gets flooded this area, and this serves as a containment system. It doesn't allow water to go to the city side. And when water comes, everybody goes home, but this one, it protects it. See here. So this is kind of it happens. Water, comes here, and the city is not allowed to flood because this is serving. In fact, if you want to raise it at the end of this structure, at the end of this one, there are hanging walls. Then you can lift them up, and then you create the additional height that you need, so that if the sea level rise is more than what you expected or surge is more expected. So those are the things that hopefully I gave you an idea about what this climate resilient design is, how we should be looking at into the future. So these kind of things have to be done everywhere. And in the US, if you have undergone the difficulties or troubles of these extreme events, you believe in doing something, and public is ready to spend money on it, right? So just I want to close, this is my last slide. So just the takeaway points are, we must consider the climate change hazards in the infrastructure design. The civil engineers, so hopefully in a matter of few years, we will have some guidance documents, and then we can use those things to teach our students in our classrooms. But right now, we really need to teach students about these climate impacts that could affect it. We should be prepared to design our infrastructure for that one. The biggest challenge in this one is estimating these extreme events. We have the science is there, but the science is very uncertain in certain things. So you have a variability, high variability, so that needs to be addressed. And there is a lack of consensus-based strategy or standards to assess the vulnerability. And then it's difficult to quantify the resiliency. And then the standard methods, as I mentioned, are not established for climate resilient design. So this is going to be the future. A lot of things are going to happen into the future. So as I mentioned, people are going to use this called adaptive management methodology, because there is no definite way of knowing the climate impacts. So it's adaptive management strategy is you design for a few years, but your design should be flexible enough to make the changes if needed into the future. So you never design something that cannot be changed into the future. So that's a kind of a concept that people are taking. If I have a retaining wall, okay, I can design for 10-meter height, but if needed, can I go into 15 meters into the future? If you don't think that one, up front, in the beginning, then the system cannot be changed. So right now the thinking is going into that direction. And then, hey, we need to solve the main root cause of this problem. That's the greenhouse gases. If we don't address the, controlling the greenhouse gases, we can do only so much on the resilience design. So it's going to be hard, as things become worse and worse. So we really need to address the root cause of the climate impacts, that is the greenhouse gases. So all of you, I was proposing this one in Vice Chancellor's meeting to teach a course on sustainability for all the students in engineering. So there should be an introductory course on sustainability to all the engineering students. So I know, based on my recommendation, IIT Dhanbad has done it. Even Tirupati, there's engineering college that has done it. A lot of universities are doing it. So I strongly suggest that your college should offer a course, general course on sustainability, for all the engineering disciplines, and it must be compulsory for all the people. Maybe you can offer during the first year of your their course. So with that one, hopefully I made a clear explanation about this emerging climate impacts and the need for addressing those in our designs. So with that one, I want to thank you all for giving the opportunity.